Okay, in this next segment, we're going to actually explore the relationship of a 45, 45, 90 right triangle. Now, when we see that both angles, both acute angles are 45, we know that that means they're going to have the same side lengths. So that is one of the big things. Another way that we call this is an isosceles. That means two sides are the same right triangle. Now, this is also always my caveat. I'm not positive that isosceles is spelled correctly there, but we do pronounce it isosceles, and it does mean that two of the sides are the same. So we are going to be using this quote unquote dot paper to the side here to draw this out. Each leg of the square is exactly 1 unit. So at first it says use the dot paper to draw an isosceles right triangle with the legs that are 3 units long. So I'm going to draw 1 unit, 2 unit, 3 unit, and I'm going to draw 1 unit, 2 unit, 3 unit. Now I can connect my triangle with the hypotenuse there. So I have 3, 3, this is my right triangle. Now a lot of people like to immediately jump in and be like, oh, 1, 2, 3. But the diagonal here has to be longer because each of these are small right triangles, and we know that the hypotenuse has to be longer. So I'm just going to leave it like this and then come back over here. So with the legs are 3 units long, we did that. Find the length of the hypotenuse. Okay, so he wants us to actually determine how long this is. We can use the Pythagorean theorem to help us out. 3 squared plus 3 squared equals x squared. 3 squared is 9, so 9 plus 9 equals x squared. And I come over here, that means x is equal to 9 plus 9. Now there's 2 ways I can do this. I can actually add these and make it 18, or I can think about 9 plus 9 is the same thing as x equals the square root of 2 times 9. Because we know that repeated addition is just multiplication. I have 2 9s. I like this way because now I can see this is x equals the square root of 2 times x equals the square root of 9. Well, we know the square root of 9 is 3, so we have x equals 3 square root of 2. And that is slightly larger because I'm taking a number and I'm multiplying it by something greater than 1, so it's ever so slightly larger than our legs. And that would make sense here. This line doesn't look super long, but it does have to be longer because it's the hypotenuse. So I'm going to give this a check mark. I believe that to be the correct answer. Part B asks us to do the same thing, but now with legs with a different length. We can choose any leg length that we want. In order to fit on our dot paper, I'm going to choose my leg to be 7. So I'm going to come over here and draw that out. So 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. And I'm going to connect it. Once again, we can notice that it is, let me use a different color, 1, 2, 3, 4, 5, 6, 7 of these different portions coming down. But once again, each of these have to be slightly larger than 1 unit. So I'm going to see if we see a similar relationship as we do above. So once again, we're going to try and find that hypotenuse. So we're going to say that 7 squared plus 7 squared is equal to x squared. So x is equal to the square root of 49 plus 49. Once again, I really like this idea of saying, oh, that means x is equal to the square root of 2 49s. When I do it this way, I can once again see that this is the square root of 2 times the square root of 49. Why is this super useful? Well, because we know the square root of 49 is 7. And now if we come up here, we should ideally be seeing a pattern. For this one, my legs were 3, and my hypotenuse was 3 times root 2. Here, my legs were 7, and my hypotenuse was 7 times root 2. So if I were trying to figure this out, I might be looking at that relationship here. We can always draw a basic triangle, or basic right triangle, thank you. Not my best drawing there. Hold on, give me 1 second to make that slightly better. We're going to say that these angles are equal at 45 degrees. We can say that if this side is length x, then this side is length x. And from the pattern that I've seen above, that means that my hypotenuse should be length x times root 2. So this is how they're all related. If you're actually in my class working on this, I would like you to actually go ahead and write a sentence or two in this spot on how you see this relationship.